Meet Maya, a busy professional rushing on a hectic Monday morning. She asks Google Assistant about traffic and follows its suggested shortcut to save time. During her commute, Spotify automatically plays Maya's favorite morning playlist. At work, Outlook has pre-sorted her emails, filtering spam and highlighting important messages. When managing customer queries, an AI chatbot handles routine inquiries, streamlining Maya's workday. At lunch, Maya notices Instagram ads for items she browsed yesterday. At home, Netflix recommendations seem so accurate to her. Puzzled, Maya wonders, how does technology know her so well? Is it coincidence or surveillance? Searching for answers, she discovers everything connects to one single term, artificial intelligence. Confused by unfamiliar concepts like machine learning, deep learning, generative AI, LLMs, Maya turns to her tech-savvy colleague Nathan, who offers to explain AI in simple terms. Nathan begins, AI isn't a magic or a stalker. It's smart algorithms working behind the scenes to simplify our lives. AI or artificial intelligence is a transformative technology in human history. But what does it really mean? At its core, AI is technology that mimics human intelligence, enable machines to think, decide, and simplify our lives. It's like giving machines the ability to learn and adapt. Think of a child learning to identify dog breeds. Initially, all dogs look alike, but with exposure, the child improves. AI works similarly. The more data it processes, the smarter it becomes. AI is already so blended into your daily life. Virtual assistants like Siri and Alexa manage tasks. Netflix and Spotify offer personal recommendations. Self-driving cars navigate roads so precisely. ChatGPT writes essays and even answers questions. These examples showcase how AI enhances various aspects of our lives, often without us realizing it. Now let's explore why AI is booming recently. AI has existed since the 1950s but remained largely theoretical until now. AI's recent boom can be attributed to three interconnected factors. First, we are generating massive amounts of data daily through our online activities, providing AI with a wealth of information to learn from and improve continuously. This data explosion feeds into the second factor, increased computing power. Advanced processors and cloud computing platforms now handle vast amounts of information at an unprecedented speeds. Companies like NVIDIA, AMD, and Intel, along with cloud services such as AWS, Amazon Web Services, Google Cloud, and Microsoft Azure, provide the robust infrastructure necessary for AI's growth. Finally, these advancements have enabled the development of sophisticated algorithms. Now, let's dive into machine learning. Machine learning is a specialized subset of AI that allows systems to learn from data and improve over time without explicit programming. It identifies patterns in data to make predictions and decisions, getting better with more data. Let me give you an example. Imagine predicting a person's weight based on their height. We collect data points and start with a simple formula. Weight equal to height minus 100, say for example. Our goal is to make predictions as accurate as possible. We adjust the line to fit all data points, minimizing the errors between the actual and predicted values. More data or variables, for example gender, can improve our model. Once trained, the model can predict weight for any given height. That's machine learning in action. Machine learning has limitations though. It requires manual feature selection. For instance, when differentiating dogs from cats, you might teach it about ear shapes. But what about an animal with features of both? That's where traditional machine learning can struggle with variation. Real-world machine learning examples include Netflix and Spotify recommendations, spam email detection. In summary, machine learning finds pattern in data to make predictions and improves over time, but needs careful setup and could potentially struggle with variation. Now let's talk about deep learning, which takes machine learning a step further. Deep learning is a subset of machine learning. Deep learning uses artificial neural networks inspired by human brain, processing information in multiple layers to learn complex patterns without explicit instructions. Imagine seeing a cat picture. Your brain instantly recognizes it without conscious steps. Deep learning mimics this, using artificial neurons to automatically learn features from data. Let's compare this to traditional machine learning for classifying cat and dog images. In machine learning, you would manually define features like presence of whiskers, ear shape, or a tail curvature. But deep learning automatically learns from millions of images. Its deep network has multiple neuron layers, each performing a specific task. One layer might detect for texture, another layer identify ear shape, and the final layer finally classifies the image. Deep learning's power lies in learning patterns without manual rules. This ability drives advanced technologies like self-driving cars identifying road objects, medical imaging detecting diseases. Essentially, deep learning gives AI the ability to think more like us as humans, learning and deciding without step-by-step instructions. Let's explore generative AI, a groundbreaking advancement in artificial intelligence. Gen AI or generative AI is a subset of deep learning. Unlike traditional AI that analyzes or classifies data, Gen AI creates new content, be it text, images, music, or even code. It learns from vast data sets to produce unique outputs that resemble its training data. Especially, Gen AI moves from pattern recognition to content creation. Now let's break down the Gen AI works through three key architectures. First, we have GANs, Generative Adversarial Networks. Imagine a creative duel between two neural networks. The generator creates fake contents like an artificial human face. The discriminator tries to spot on if it's real or fake. It's like fraudster acting like a generator and a detective acting like a discriminator, constantly improving their skills. This technology powers deepfakes today and AI art tools like DALL-E and Midjourney. Next, we will look at variational autoencoders, also known as VAEs. These focus on creative variations. They compress data into a simpler form and reconstruct it with new twists. For instance, you could input a photo and a painting style, and VAEs would transform your image into desired painting style. They are also behind voice mimicking and style transfers. Finally, we come to transformers, the engine behind today's ChatGPT. These process text using self-attention to grasp word relationships. Here's how it works. It breaks sentences into tokens. Let us take this example. She went to the bank and this gets tokenized as individual words. It then analyzes the context. Bank could mean a financial institution or a river bank, depending on its surrounding words. If the context is bank, most probably, then the following predictions could be withdrew, deposited, or even waited, etc. Let us take another example. If we ask, who wrote Harry Potter? The transformer encodes the question, understanding wrote implies an author and Harry Potter is a book, and the decoder predicts the answer as J.K. Rowling. This powers ChatGPT's ability to generate coherent text, answer questions, and even hold conversations. In essence, Gen AI creates a new content using GANs for images, VAEs for variations, and transformers for text, revolutionizing everything from self-driving cars to chatbots. Let's reflect on AI's incredible journey and its future trajectory. AI has made remarkable strides in language processing, real-time decision making, and automation. But before we reach something called AGI or Artificial General Intelligence, let's explore an emerging concept, Agentic AI. Agentic AI doesn't just process information, it acts independently to achieve goals. Imagine an AI assistant that manages your calendar, automatically tasks across multiple applications, conducts research and summarize findings, all without human constant input. On the horizon is quantum AI, merging quantum computing with AI. Unlike classical computers using bits, zeros and ones, quantum computers use something called qubits. These can represent 0, 1 or both simultaneously, enabling much faster processing of vast data sets. For example, a quantum AI could simulate complex molecular interactions for drug discovery. The ultimate goal? AGI, Artificial General Intelligence, a system that thinks, reasons, and improves itself. Experts predict we may reach the singularity by 2045, where AI surpasses the human intelligence. This presents both incredible opportunities and profound challenges. As AI advances rapidly, we must consider how will we coexist with super intelligent machines. Are humans at risk of being outpaced by AI sooner than we think? Let's wait and watch. In healthcare, AI detects diseases like early stage cancer in medical scans with greater accuracy than human experts. Financial benefits from real-time fraud detection systems analyzing millions of transactions to spot suspicious patterns. Education transforms through adaptive platforms that tailor lessons to individual student needs. Manufacturing sees automated production lines boosting efficiency, while transportation advances with self-driving technologies like Tesla's autopilot. Meanwhile, creative fields explode with innovation, like tools like DALL-E for crafting stunning images from text. By 2030, AI could add $15.7 trillion to the global economy. However, this brings challenges like job displacement due to automation, or an AI arms race between nations like US and China. With great power comes great responsibility. AI, especially quantum AI, poses risks if misused. AI-controlled stock markets could trigger crashes. AI-driven medical treatments could cause harm or even death. Who's responsible when AI causes damage? The programmer, the company, or the AI itself? Without proper AI regulations, we face serious risks. Deepfakes could spread widely, causing misinformation. Autonomous weapons might operate without ethical constraints. Economic inequality could worsen as jobs are automated. We need laws enforcing AI transparency, accountability, and ethics to ensure AI remains a force for good. Over-reliance on AI can dull our creativity and independent thinking. Use AI as a partner, not a crutch. Balance AI use with human skills like intuition and problem solving. We have evolved from cave paintings to coding. Don't let AI erode our unique abilities. AI has immense potential to improve our lives and solve global challenges, but its future depends on our responsible guidance. Together, we can create a world where humans and AI collaborate for a smarter, kinder tomorrow. Maya finally thanked Nathan for explaining AI's importance and responsible use. Nathan reminded her that while AI enhances our lives, we must stay in control to ensure it benefits everyone. That's all for today. What topic should we explore next? Comment below. Don't forget to like, subscribe, and hit the notification bell. Let's keep discovering the wonders of future technology together. See you.